Exercise 8C, quadratic functions. Alright, so as we did for exponential functions, we're going to focus one lesson on the graph itself and the features of the graph and how to draw it and things like that. And then we will do exercise 8C, where it's quadratic models, where we apply them more to real life situations and different scenarios, and more, I guess, exam style questions. Alright, so quadratic functions. A quadratic function is a curve whose equation has an x squared. It is defined by the general rule y equals ax squared plus bx plus c. Sorry, should make that thicker. Where a, b, and c are numbers. Okay, and those a, b, and c, those numbers will do things to the graph. They'll transform them. Transforming a graph means moving a graph around the axes. Okay, up, left, right, down, whatever it might be. A quadratic function will give you a parabola. Okay, so it can look like this, or it might look like a sad parabola. Okay, and we know it's a parabola because the highest power in the equation is a power of 2. Okay, so let's have a look at some of these key features and highlight, I guess, those that are most important. The basic parabola has the equation y equals x squared. Okay, so we can add or subtract things from that and do different things to move it around, but y equals x squared is a parabola that will give you origin at 0, will give you a vertex at the origin. The vertex or turning point of that basic parabola is the origin. It is a minimum turning point. So a minimum turning point is when it's like this. When it's a sad parabola, it's got a maximum turning point. It's a maximum, minimum. Axis of symmetry is at x equals 0. So where can you fold your parabola in half? Remember, a parabola is... Oh, I've gone blank for the word. It's got an axis of symmetry, so it's a reflection, on either side. So when you fold it down where the vertex is, and when it's your basic parabola like this one, that, I guess, axis of symmetry, that line is the y-axis. The y-intercept is at 0, x at 0. We know that because that's where the vertex is. The graph y equals minus x squared is a reflection of the graph y equals x squared about the x-axis, so meaning it would be down there. Changing the coefficient of the equation, such as 2x squared or a half x squared, affects the height of the parabola. I don't like the word height. I like to think of it being a fat or skinny, okay, which is probably not very nice, but that's how I remember. A half is a fatter parabola. A whole number is skinny. So the smaller the number in front of the x squared, the fatter the parabola, so the wider the parabola, okay? Now, adding or subtracting a number to the equation, such as x squared plus 1 or x squared minus 1, does not change the shape, but it moves the parabola up or down. All right, we'll have a look at those sorts of things. Now, just a summary. So a quadratic function in the form y equals ax squared plus bx plus c, where a, b, and c are numbers. That's your equation. Parabola with a minimum turning point is y equals x squared, so it's happy. Okay, because that x squared is positive. Because this one's a negative, it's a sad parabola. Okay. Now to graph a parabola, construct a table of values, draw a number plane, plot the points, and join the points. Okay, so you don't have to be able to graph these via transformation. All parabolas that you need to graph, you are able to use a table of values. Okay, so draw the graph of y equals x squared plus 1. You probably, with a parabola, I would say you need 5 points just to get a better idea of the shape. 3 wouldn't give you enough. Okay, I always like to put the origin as well. So I usually go minus 2, minus 1, 0, 1, and 2. Okay, and you know it's a reflection, so you should be seeing the numbers repeat. Alright, so if I go minus 2 all squared plus 1, that'll give me 5. Let's do it another colour. Minus 1 all squared plus 1 will give me 2. 0 squared plus 1 is 1. 1 squared plus 1 is 2. And 2 squared plus 1 is 5. So there's our table of values. Now to graph that, just set... Oh, it's a bit thick, isn't it? I think that's also a bit thick. Alright, so just set up your parabola. something like this. And I'm noticing that all of my y values are positive, so I'm just going to drop this axis down a little bit. That's why I like to do my table of values first, so that I can position things properly. So I'm going to go 1, 2, minus 1, minus 2. I'm going to go 1, 2, 3, 4, and I've just made it here up at 5. Okay, so let's graph that. So minus 2 and 5 is up here. Minus 1 and 2 is here. 0 and 1 is here. 1 and 2 is here. And 2 and 5 is here. Okay, so if I join those points, there is my parabola, and it continues, so you can put arrows on the ends. Alright, this one wants a little bit more. It says draw the graph of y equals x squared minus 4x plus 3. Use x equals minus 1 all the way to 5, I guess because we need to get a better shape. So because they've told us to do that, we'll do that. And find the following features. So let's do our table of values first. I'm going to just do it here. So x, y. Okay, so minus 1, 0, 1, 2, 3, 4, 5. Okay, so substituting that into the equation. So minus 1 all squared minus 4 times minus 1 plus 3 will give me 8. I'm going to use a calculator. Now I've done all the rest, so I'll just copy them in to save you some time. But I would just shove them all in a calculator, because that way I could just go back and swap my x value if I put it in brackets. Alright, now let's graph this. Now all my y values are positive again, so I'm going to I will kind of position my axes to allow for that. So I'll drop them, well, they're not all positive, but most of them are, so we'll just go like this. Alright, and then put some of those numbers in. Now I'm going to have to go up, I'm going to have to go up by ones. 1, 2, 3, and you don't have to write all these numbers in, I don't know why I have. Just makes it look a bit messy, but that's alright. Minus 1, minus 2, 1, 2, 3, 4, 5. I'm just going to put the numbers that are on my... Oh, and I've got a minus 1 down there, don't I? Alright, let's start graphing. So minus 1 and 8, 0 and 3, 1 and 0, 2 and minus 1, 3 and 0, 4 and 3, and then 5 and 8. Okay, if I join all those points, I get a parabola that's gone a little bit down there. Okay, so arrow, arrow. Now, we need to answer some questions. So A asks, where is the turning point? Well, the turning point is that point there, so where it changes concavity. So the turning point is at 2 and minus 1. Okay, where is the axis of symmetry? So the axis of symmetry would be that fold line down the centre, where the probably got to that thinner, where the turning point is. So this is your axis of symmetry. Okay, so your axis of symmetry is at x equals 2. Where is the y-intercept? Or the y-intercept, let me pick another colour, is here. So the y-intercept is at 0 and 3. D, where are the x-intercepts? What colour haven't I used? Green maybe? That would be here and here. So my x-intercepts are at 1 and 0, and then at 3 and 0. And then the last one, what is the minimum value? So the minimum value, pick another colour, could be this one here. The minimum value is the lowest, would be over here as well. So that our minimum value is at -1. So at x equals -1, so that minimum value is across there. Okay, that's the lowest point. Alright. For this, you could also just write that your x values at your x coordinates are x equals 1 and x equals 3 and y equals 3 if you wanted to do it a bit shorter. Both answers are correct. Alright, have a go at that exercise.